In this section, we're going to touch on quickly glabrous skin and arteriovenous anastomoses. There'll be a lot more in Module 8 when we talk about palm cooling. But just to go over these are specialized areas found in the palms, soles of the feet, and upper face. They're referred to as glabrous skin. They are characterized by an absence of hair follicles. They also have AVAs, arteriovenous anastomoses, which are special capillaries that create this dense vasculature network. So the AVAs, they are direct connections between arterioles and venules. They bypass capillary beds, and they really they function as high volume shunts for blood flow. So when they are opened up, for example, during hypothermia, they can increase skin blood flow 10 to 15 times. But they also shunt, so they also close off. And this is why you'll have very, very low blood flow in your fingers and toes in cold temperatures and get frostbite. So when combined, you have this dense vasculature, a lot of blood flow, you're in a state of hyperthermia. If you can have contact with surfaces, you can maximize conductive heat transfer through these portals, through these radiators on the body, you can have a significant amount of heat transfer. This is a visual which is apparently quite blurry in this, that shows exactly what these are. Now, another note is that the AVAs, the arteriovenous anastomoses, they don't actually pass nutrients or substrate into the surrounding tissue or muscle. So unlike regular capillaries, their real only function, their real only purpose is blood flow. So you'll see their ability to vasoconstrict or vasodilate drastically changes the amount of blood flow that passes through the glabrous skin. Now, there's a lot of different reasoning and rationale, and the article by Wallow is probably the best at exploring this, but evolutionary adaptation served as efficient thermal radiators. You do see this in a lot of animals. For example, the fennec fox has glabrous skin in the ears, and they live out in the desert. That's a primary mechanism of cooling. And then the human hand, as well as the bottom of the feet, really, really optimized for heat transfer into the environment. So the practical implications. Palm cooling, this is what we're going to talk about a lot in Module 8 and 9, is a very effective and easy strategy for managing thermal load because it takes advantage of the anatomically optimal interface on the body for heat transfer and to dump heat out of the body. Face and foot cooling also be effective. They generally run into a little more difficulty in terms of practicality or accessibility, people wearing shoes and socks, and then the face being, a little either less accessible if you're wearing helmets, as well as just more difficult to comfortably cool effectively. But really, the advantage to glabrous skin cooling is that you're cooling by conduction, and it's the vasodilation. So in hot, high humid environments, you're still able to effectively transfer heat out of the body, despite the high humidity, whereas sweat can often falter or really struggle to dissipate heat when there is high humidity.